Of all the 7 jets coming from the surface of the central object, some of them towards the sun, some of them away from the sun. What surprises me is that they are tightly collimated.
November 2025. Astronomers capture a new series of frames of 3I Atlas, the third confirmed interstellar visitor. And right away, something doesn't line up with the physics we know. A long, thin jet of material, extending forward, directly toward the sun, stretching nearly 1 million kilometers into space. Out here, the solar wind screams outward at nearly 400 kilometers per second. Natural comet gases drift outward at around 400 meters per second. Yet somehow, this structure holds its shape. A narrow river of material pushing straight into a headwind more than 1,000 times stronger than anything a natural comet should withstand. It's like watching someone stroll calmly into the center of a hurricane and never being blown backward. And it's been happening for weeks. Here's the part scientists hate talking about. If you run the equations required to justify this as a normal comet, you end up with a mass loss rate that exceeds the total mass the object should even possess. That is why multiple research teams have tried submitting papers. And that's why every major journal has quietly turned them down. Not because the math is broken, but because the implications make people extremely uncomfortable. Subscribe if you want the parts NASA isn't emphasizing, because the clearest images of 3I Atlas aren't coming from billion-dollar spacecraft. They're coming from backyards. And the patterns those observers are revealing don't fit the official narrative. Let's start with where this object even is. 3I Atlas drifted into our solar system earlier this year, an interstellar visitor on a hyperbolic path, cutting through our system from somewhere far beyond. It passed perihelion on October 29, and now it's heading out. We won't get another chance to see it again. Right now it sits roughly 300 million kilometers from Earth, double the distance between Earth and the Sun, and in just over 2 weeks it will make its closest approach to our planet since the moment Hubble first locked onto it back in July. Comets moving away from the Sun should settle down. Less heat means less sublimation. Activity collapses. The coma fades. The tail shrinks. The object's glow drops steadily. But that isn't happening here. Instead, amateur astronomers are still capturing razor-sharp frames, active jets, clear structure, flickering brightness patterns that should have disappeared by now. And this leads us straight into the anomaly that triggered the current debate. Look closely. You see 2 tails. One stretches away from the sun, the normal orientation. Solar radiation always pushes dust and gas backward. But the other tail, the long, slender one, pointing toward the sun, is the anti-tail. And unlike rare geometric illusions caused when Earth crosses a comet's orbital plane, this one isn't caused by perspective. Earth never crosses the object's orbital path. Nothing in our viewing geometry can create this effect. This forward tail is physically real, and it extends for almost 1 million kilometers. Now here's where the physics breaks. Solar wind at this distance travels at nearly 400,000 meters per second. Material released from a natural comet moves at maybe 400 meters per second. For tail material to persist against that force, the density would need to be over 1 million times greater than the surrounding plasma. If that were true, 3I Atlas would be shedding nearly 200 metric tons of material every second, just to maintain the forward stream, and that's assuming a minimal cross-section. Realistically, the number is much larger. Across October and November, that mass loss adds up to billions of tons. About 10% of the lowest mass estimate proposed for the object, 33 billion tons. And here's the uncomfortable part. NASA now says the nucleus is probably smaller than those early estimates, which means losing 10% of its mass should have cracked it apart, but it hasn't fractured. The object remains stable, intact, coherent. Now let's look at the motion. Natural comets experience something called non-gravitational acceleration, little nudges caused by uneven outgassing. These shifts alter the orbit slightly, but all through the summer, 3I Atlas showed 0 deviation. It moved like a dense rock, predictable, steady, with no sign of thrust from sublimation. Then October 29th happened, perihelion. The moment it slipped behind the sun's glare, its trajectory changed. Suddenly there was measurable acceleration. For that acceleration to come from natural comet behavior, the object would need to eject over 10% of its mass at high velocity. But we already calculated the 10% mass loss needed to maintain the anti-tail. Add these together, and the math collapses. A natural comet would have needed to lose 20% or more of its mass in 2 months. A small icy body cannot survive that, or it implies the object is far more massive than measurements indicate, contradicting thermal data, brightness models, and density estimates, which leaves one final possibility: chemical propulsion, or ion propulsion. Rocket exhaust travels at around 4.5 kilometers per second. Ion drives operate at tens of kilometers per second. That's 10 to 10,000 times more efficient than natural sublimation. If you plug in those numbers, the mass budget works, the acceleration works, the intact structure works, the forward jet works, the physics works, and that is the conclusion several researchers have already submitted for peer review. Not fantasy, not speculation, cold calculations, consistent physics, whether journals want to touch it or not. Every major journal has rejected the submitted papers outright, not delayed, not debated, simply dismissed, and once again not because the equations are flawed, but because the conclusion unsettles people. There's another detail that's becoming harder to ignore. The anti-tail remains intensely collimated, tight, structured, almost unnaturally straight. It has held that razor-line shape for days, but 3I Atlas rotates once every 16 hours. If the jets were bursting from multiple vents on the surface, like natural outgassing, the rotation would twist them outward. You'd see spirals, fans, arcs, patterns flickering as each active region swings into sunlight, then slips into shadow. But that isn't what we see. Instead, we observe a uniform continuous column, as if the source of the jet either doesn't rotate, or adjusts to counter the rotation perfectly. The only natural workaround would be a single vent firing only when exposed to the sun, but if that were the case, the jet would pulse, switching on and off, a rhythmic heartbeat tuned to the rotation period. We don't see that either. The jet is constant. Then comes another inconsistency. As 3I Atlas spins, its brightness shifts by 10 to 20%. NASA has said repeatedly that most of its light comes from the coma, the envelope of gas and dust around the nucleus. But the coma doesn't rotate with the solid body. A comet's gravity is far too weak to drag that diffuse cloud around in sync with its spin. The gas should stay almost uniform, regardless of the nucleus's orientation. Yet amateur astronomers keep capturing brightness changes that align perfectly with the rotation cycle, along with shifting gas structures that should not behave that way. This shouldn't happen, not with a natural coma. And now we reach something even stranger. 3I Atlas is heading toward Jupiter, not on a collision course, just a flyby, but the alignment is precise. Its trajectory was originally calculated to pass directly into Jupiter's Hill radius. The Hill radius is the border where Jupiter's gravity dominates the Sun's. It's the edge of the planet's gravitational sphere of influence, an ideal place for leaving something in orbit, performing station keeping, or deploying a monitoring device. We use similar gravitational pockets all the time: Lagrange points, stability zones, dynamical parking lots where satellites and probes can remain with minimal energy. Initial calculations showed 3I Atlas would pass inside that Hill radius in March 20, so precise that it fell within one standard deviation. Avi Loeb, the Harvard astrophysicist, tracking the object, sent a formal analysis to NASA's Jet Propulsion Laboratory, highlighting this strange precision. JPL didn't reply, but within days, their trajectory model quietly changed. The non-gravitational acceleration value was updated, first by a factor of 4, then 6. The new projection, 3I Atlas, will now pass just outside the Hill radius. Very convenient. So the question becomes, how does an agency like JPL miss something this significant in their initial calculations? And why did the correction appear immediately after Loeb's report landed on their desk? Loeb didn't mince words. He compared the situation to the Vatican insisting Earth was the center of the universe. Their belief didn't change the reality of Earth's orbit. In the same way, updated models won't change where 3I Atlas actually travels. In March, we'll see the truth. We have spacecraft near Jupiter, Juno, JUICE, Psyche, that will monitor the flyby. Amateur astronomers will track it too. The data will reveal exactly where the object passes, and if it crosses into the Hill radius despite NASA's revised forecast, the questions won't be easy to dismiss. Here's what is certain right now. 3I Atlas has an anti-tail nearly 1 million kilometers long that shouldn't survive solar wind pressure. It is shedding mass at a rate that should have shattered any natural body its size. It showed zero non-gravitational acceleration for months, then suddenly accelerated when it was hidden behind the sun. Its jets do not behave like jets on a rotating body. Its brightness varies in ways a normal coma cannot explain, and it is headed toward a gravitationally special region with uncanny precision. None of this proves artificial origin, but the natural explanations rely on physics we've never seen: mass loss rates that break structural limits, tail behavior that contradicts ram pressure, trajectory coincidences that stretch chance beyond believability. Meanwhile, the artificial explanations, ion thrust, chemical propulsion, active stabilization, fit the numbers without contradiction, and the papers showing these calculations still cannot find a journal willing to publish them. In 18 days, 3I Atlas makes its closest pass to Earth. Hubble, James Webb, and nearly every major observatory will be watching. We'll capture clearer imagery, higher resolution spectra, and more data than ever before. In theory, the object should now be fading, cooling off, losing activity, shrinking into a dark, quiet nucleus. But if the recent pattern continues, we may see something very different. Sustained activity, stable jets, anomalies that refuse to resolve into anything natural. Then in March 2026 comes the Jupiter test. If 3I Atlas enters the Hill radius despite the revised official numbers, the coincidence becomes a pattern, a signal, a decision point. This isn't about chasing conspiracies or claiming extraterrestrial engineering. It's about following the physics. Equations don't care about belief. Trajectories don't bend for convenience, and data doesn't lie. Right now, the natural explanations require extraordinary exceptions. The artificial explanations require nothing more than ordinary engineering. Extraordinary claims need extraordinary evidence. But no one is making extraordinary claims. We're simply asking why the ordinary explanations keep failing. The next few months will decide everything. Not models, not revisions, not institutional discomfort. Data. Actual observations from multiple independent sources. We are witnessing something unprecedented. Whether it's new physics or something deliberately engineered, the truth is approaching. Remember March 16, 2026. That's when the numbers stop being theoretical. That's when we see where 3I Atlas actually goes. And that's when we learn whether NASA's revisions reflect reality, or whether they were meant to bury an uncomfortable trajectory that never changed at all.